how and why I wrote Inkwell, name of the program. It started as a program with a simple but mostly unspecifiable purpose. And as problems popped up, ideas popped up to address them, and the direction of the work changed. Though officially retired, I still work on it. My purpose is to address the concern of Geoffrey Jefferson, who wrote in 1949, "Not until a machine can write a sonnet because of thoughts and emotions felt, and not by the chance fall of symbols, could we agree that machine equals brain. That is, not only write it, but know that it had written it." So let's start with some examples. This is stuff that my program has written. Deep in the dark, the power of snow, walking in the deepness. It can revise work and make it sound like someone else. So here is the famous Stopping by Woods by Robert Frost, to make it sound like Ernest Hemingway, using short words, the first and last stanzas. He gives his harness bells a cloud, to ask if there is some spot. The only other music is the illusion of worn wind and cold mound. The logs are good, glad, and tight, but I have words to keep, and miles to go before I sleep, and miles to go before I sleep. A crooked rag day, by myself, dunking distracted sardines. Day after day, in the man's can, a man can. You can ask it to keep some thoughts in mind while writing haiku, and my colleague Ron Goldman said, have it write something about blues guitar and loud music, and this is what it wrote. This is the first one it wrote, no revision. Tuned adrenalin, my music, a beat-boogied headful. Oops. So, computery stuff, not this fatalist murderousness death watch, but your dead subroutine. Functional function, the orchid, even when it's lisped functionally. So what? So in this talk, if you think you're going to learn something useful for your job, you should leave now, because I'm not going to tell you anything that's any use whatsoever. But I am going to explain how writing programs can be weird. And I'm also going to try to make the point, but I won't argue it explicitly, that back in the 60s, 70s, and 80s, old style AI was not enough, and that today, the new style is not enough. I don't know why I keep jumping ahead. So this started with a broad agency announcement by DARPA, which was put out in July of 2011, called Social Media in Strategic Communications. I was working at IBM Research at the time. The goal was to identify malicious persuasion campaigns, map out who the players were, not figure out their names, but figure out how many players there were and identify them. Figure out who they would listen to, who was susceptible to being persuaded to not do the malicious campaign, and to direct messages toward them. So this was answered by IBM Research. I had nothing to do with the proposal. The proposal said, as item 3.4, we propose to develop technologies and tools for automatically or semi-automatically generate and tailor counter messages to different target audiences. So someone that I went to school with said, oh, you did a natural language system for your dissertation, why don't you work on this? So I said, okay. So the initial plan was simple. Some other part of this big program that was going to be put together by this large conglomeration of universities and companies would create a template for a text which would be a counter message to someone. My program would be told a target personality. So make this message where it has this content, take that content and make it exhibit the following personality. Mark some of the words to change in the original text, find alternative words, measure the personality of the potential text, of the altered text, and optimize to get as close as possible to the target. Okay? So the group that I was in, they specialized in sentiment analysis and personality stuff. So the initial idea was to take something like the woods are lovely, dark, and deep, find a bunch of alternatives like attractive, beautiful, colorful, dishy, etc. Make these change swaps, measure the result, and optimize using simulated annealing, which I used because it's a discrete space that has no gradients in it, no obvious gradients. So as I said, the group that I worked in specialized in personality analysis using text. And they used the Big Five. This is called the Big Five. It's also called OCEAN because of OCEAN. So openness to experience, conscientiousness, extroversion, agreeableness, and neuroticism. And neuroticism doesn't mean crazy. It means the opposite of emotional stability. So you get some impulse and you react to it quickly, and that's neuroticism. So this is based on the work of James Pennebaker, who produced a thing called the linguistic inquiry and word count idea, which is you look at the words in a text, they get categorized into these 68 categories, and then thereby you learn something about the text. So, for example, any word that starts with C-O-O-K, cook, gets categorized as physical states or eating and drinking. So it scans the text, counts how many words fall into these categories, and then comes up with something. This was followed by some other research by Tal Yarkoni, which mapped the percentages in the different categories to the Big Five personality thing. So what do I mean by that? So if you have this text, which I'm sure all of you have written at one time or another, reading Gabriel's essays is pure agony, then this process would work like this. You would map it into the categories, which that dictionary, the Luke dictionary, provided, and you would get this count number of words, it's this percentage of words. And then it's just a simple linear combination using the so-called Yarkoni coefficients to come up with the strength of that personality trait. And that means that not very agreeable, not conscientious, no evidence about extroversion, a little bit neurotic, slightly not open. So that's the personality of this text. Okay? Is that all clear so far? So problem number one. Almost all of the texts that were going to be sent and all of the texts that were going to be analyzed were tweets. Okay? And the sentiment analysis that my group had was based on the Luke 2001 dictionary, which maps the words to the categories. There was only 2,319 words. So many tweets, there would be no words that were in the dictionary. There was a second dictionary called Luke 2007 that had almost 4,500 words, and it was better vetted, meaning that a bunch of psychologists worked harder on it. But they had different category names, they had a different number of categories. And so the first task was to import those words by using the dictionary overlap, so common words between the two dictionaries, to come up with a numerically weighted mapping of categories in the 2007 to the 2001 dictionaries. Okay? And I used an old AI idea of certainty factors to combine weights. Okay? So that gave me almost 5,000 words in the dictionary. Still not enough. So, as you noticed, I need to find words to substitute for the original to see if I can get closer to the personality. So I need synonyms. Thankfully, there's a thing called WordNet, which is a dictionary that's provided by Princeton University, and every natural language processing researcher today uses WordNet as the basis of almost everything they do. So, because I'm kind of a nerd, there's two versions of the dictionary, so I combined them and came up with about 160,000 words, and the WordNet entries look like this, more or less. So it talks about different types of synonyms. Turns out there's like 7 or 8 different types of synonyms. So for example, a hypernym is a superclass, a hyponym is a subclass. There's a dictionary definition. So this is for dog, a domestic dog, a member of the genus blah, blah, blah. There's a hypernym chain, which is kind of like an ontology, and a whole bunch of other synonym types. So that's going to be the basis for finding the words. So I needed more words for Luke. So the first thing was to try to grab them out of WordNet. So the way I did that was the words mapped to a bunch of synonyms using WordNet. For every word in the Luke dictionary, I find the synonyms, I add them, and when I add a synonym of a synonym, I degrade the weight of it, and so the degradation factor is 0.75. So I kept on doing that until it added no new words. And that ended up with 31,000 words in the Luke dictionary. And then I used the original dictionary on large texts and the original Yarkoni coefficients to basically backlearn coefficients for the expanded dictionary, and we decided to call those the RPG-only coefficients. So that's a joke in case you don't. The other thing is, turns out a lot of the texts that we had to deal with were full of swear words, and there weren't very many in the original Luke dictionary because they were proper Texans who did it. And so I found a list of 458 swear words and bad words, and so we ended up with 31,473 words. Okay? So, next problem. I happen to be a writer, a trained writer, and I had no idea about any of this personality stuff. I had no idea what it meant. So the natural thing I did was try it out on literature that I happen to have. And what I noticed is that the personality seemed to track the genre better than it tracked the writer. Okay? So it was an interesting problem. We talked about it in the group, but they didn't really think it made any difference. And so to show them, I trained a classifier using personality traits to categorize texts into genres. And then I'm going to show a sample of some of the test results of applying it to text that I've never seen. So the first, Not, Trackle, Lanier, The Wasteland are all poems, and it classified those as poetry. Moby Dick it classified as fiction. The Constitution is nonfiction. To Kill a Mockingbird is fiction. For Hamlet, played by Shakespeare, it computed a sort of a mixed genre of mostly fiction, a little bit of poetry. Bertrand Russell essays, nonfiction. Babbage, nonfiction. Darwin's Origin of Species, nonfiction. In Memoriam, it made a mistake, called that fiction. The Bible, sorry Quux, mostly fiction, a little poetry. And then a book, a nonfiction book by a fiction writer, mostly fiction, partly nonfiction. So this means that if you have someone who's a trained writer, then the personality is going to be the personality of that genre more so than the personality of the person. But the DARPA project didn't care about that. And here's tomorrow's keynote speaker. So, basic approach is to assume that these templates for counter persuasion campaign messages come from somewhere else. And these templates will create choices to make. It's a simple language. And they compile into optimization problems. So basically what you want to do is take some text, lay out the different ways you can phrase it, and then pick the one that matches the personality the best. So it creates a misfit function, to use the terminology that Daniel used this morning. So a stupidly simple one is, I have a word meaning big, word meaning fat, word meaning dog. So this is a template, okay? And so when you hand this to Inkwell, the early version, it says, oh, I have a great heavy dog, I have a big heavy dog, I have a large heavy dog, I have a great heavy cur, I have a big fat cur, okay? And to sort of visualize the search space in the synonyms, these are the network of words that it looked at as alternatives. That's the one for big, dog, and fat. And so one of the parameters is how far out to look from the original word and how much to decay the relevance once you go that far. So today there's a user interface that I use just to show you what that looks like. This is in 2018, and the original one that we were just talking about was in 2012. So this is the Big Five personality and a bunch of other things, what types of synonyms to look for, and various parameters for how to decay, etc. A whole bunch of other parameters that can be used to customize what it does. Okay? So the next problem is that WordNet uses basically the root version of the word. So when I need to do conjugation or declension, I have to create those things. So I take a basic word and adjust it. So this is the only place in Inkwell where code knows about English. The dictionary, the WordNet dictionary, there's a version for, I think, 22 different languages. And my program doesn't care which language it is. But here, this part does know about English. This is the only part that knows about English. So what I mean by adjustment, if I have the word dog as a noun, I want to be plural, it produces dogs. If I have the verb have, I want past singular, it produces had. If I have the verb have, and I want the first person singular, future perfect, indicative, then it produces will have had. And if I say hard to please, so WordNet has phrases, not just words, as an adjective, and I want it to be superlative and capitalized, it would produce hardest to please. So soon it became clear that I needed to control a little bit of the thinking that Inkwell did, and so the template started to become a DSL. So here there's a binding thing. It says find a word that means fat, and then use it here and use it there. So I have a big, fat dog. He is just too fat for a dog. And this produces, I have a big fat dog, he's just too fat for a cur. I have a great heavy Pekingese dog, he's just too heavy for a dog. I have a big abdominous dog, he's just too abdominous for a dog, etc. And so here's fat, and there's abdominous. And this is an example of how the relevance decays. So if I pick a word like roly-poly, it says, well, that's kind of a weak choice. And here's the network that I look at for domestic dog. So I mentioned that Inkwell, to use Graham Hutton's terminology, calculates a misfit function. For the early versions of Inkwell, this is an example of the misfit function. You can see up here the deadly clue that it's Lisp that has a local macro, and it just calls the personality analysis. So problem number 4. Even though every revision is guaranteed grammatical, if the template is grammatical, many revisions are nonsensical. So how many people are programming language theorists in here? So notice the word guarantee. Notice the word nonsense. So it's guaranteed to be type correct, but complete nonsense. So just remember that. Do with it as you will. So what I mean by that, so if I give Inkwell sort of free rein to have fun with this, it will produce stuff like this, guaranteed grammatical. I amass a big heavy dog. I stalk a big abdominous dog. I economized a big heavy dog. I computerized a big heavy dog. I husband a big abdominous dog. So why is that? It's because WordNet points out, and we all know, that some words have many different senses. So what I mean by that, so here's different senses for the word hacker. So there's hacker as is someone who plays golf poorly, that's the first choice. A cyberpunk, which is a cracker. A hacker, so these are like people at MIT, true hackers like Quarks and me. And a hack is someone who works hard at boring tasks. I won't make the obvious joke. So plan number 4, use Engrams to control sense. So that's first part. Second part is to use WordNet in a smarter way. And then the third thing is to use, go beyond synonyms, and that's a little bit later. So what are Engrams? Engrams are strings of words that appear in a text. So here are a bunch of 3 grams, are huge and, one copy of, sooner rather than, was wrong and. So these are 3 words in a row that appear in a text. And then the numbers are sort of a measure of how common it is in that text. So being completely crazy, I decided to use the Google Engrams. So something that Google provided, they scanned in every book from 1910 to 2010 or something like that. I created a small sample of that, only 50 million Engrams. It took 2 weeks of every computer in my house to download them. It took a month to clean and process them because they were OCR'd, and so they were full of junk. Thanks to Sergey Brin being Russian, he scanned in a whole bunch of Cyrillic texts, which just turned into nonsense, gubbish characters. And so it took a month of CPU time, a month of 16 CPUs to clean it up. So thank you, Google. So how can we use something like that? There's some clever representations I won't go into. So the phrase big fat is a 2 gram, that appears. The 2 gram fat big doesn't appear anywhere. Never been written down in English books, or Cyrillic books for that matter. So you can use the templates to sort of say, I like, well, it's either fat or big, call that FB. And then the next word is either fat or big, but it has to be different from the previous one. And it says, I like big fat dogs because the Engram said so. So again, Inkwell didn't know anything about the language, but used the Engrams to do that. And then that's because this is the basic order of acceptable adjectives in English. Opinion followed by size, followed by age, followed by shape, etc. So you can't say fat big. So here's a little more accessible set of senses. My favorite word that I use for examples is dog. There's 8 primary meanings for dog. One is domestic dog, like your pet. There's a dull, unattractive, unpleasant girl or woman. Sorry, I didn't make that up. There is, in an informal term for a man, you lucky dog. There's a cad, someone who's morally reprehensible, you dirty dog. There's a wiener, like hot dogs. There's detent, which is if you have a ratchet thing, this thing is a detent. And an andiron to hold up logs in a fireplace, and the human foot. So if I say to Inkwell, find me something that means dog, and I'm not very precise about it, like I like dogs, and I say, I don't care which sense you use, I like feet, I like huskies, I like detents, I like clicks, I like parachutes, curs, toys, black retrievers, heels, peaks, Newfoundlands, hounds, franks, cads, wieners, andirons, puppies, barkers. So grammatical, but nonsensical. So why is that? Here's the network for dog, starts in here. Here's the domestic dog cloud. Here's the other dogs. Here are the other dogs. So you have to account for that somehow. So the first way is, if you looked at the senses, there was this semantic label. So noun, animal. So there was a couple of noun persons, there was noun food or something like that. So I say, I like dogs, it's a noun, pick me an animal. Then it'll say, I like dogs, huskies, curs, toys, retrievers, geeks, and blah, 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 blah. So you can kind of zero in a little bit better. So then we discovered that personality was not the best way to model a writer, that we saw with the use of Engrams, that the Engrams could influence things. So maybe we could have it as a model of a writer, their personality plus their Engrams, the way that they talk, things they talk about, the way they talk about it. Okay? So we can use the Engrams in addition to personality. We can be smarter about using WordNet, but we're still going to get some nonsense. So here is a sentence, or two sentences that I put in. I met a woman, so verb past, noun person, on that day, noun time. The wind, a phenomenon, was either blowing as weather or blowing as motion. So then, I use the King James Bible as the Engrams. And interestingly, almost all of the variation is on the second sentence. Here, wife is selected over woman just once. These are the first, however many, these are 10 that Inkwell came up with. So this is the best to the worst of the top 10. And you can see blowing, storming, streaming, blasting, breath, wind, air, etc. So now I mentioned at the beginning the angry type theorist. When I use his textbook, then you'll notice that all of the variation is at the beginning, and some of it's kind of odd. So char, because there's chars and ints and all that sort of stuff, char happens to mean a human female employed to do housework. I didn't know that. Baggage, worthless or immoral woman. I didn't make up these definitions. So. And then to explain this stuff, well, even and odd, that's easy. Streams, he talks about streams, draft. Why does he talk about draft? Every page of the textbook has the phrase July 22nd, 2020, draft 1713. Interestingly, if we look at the frequency of words, draft is number 45 on the list. Type is 14 slots ahead of the word if. Just saying. So, So the simple synonym search, even with Engrams, still produces nonsensical stuff. Technically, it's grammatical, but now it's starting to look a little bit interesting. Okay? So in 2014, I was all done with SMISC, social media in strategic communication. So I changed what I was working on, still working at IBM Research, to assist human creativity and mimic a specific writer. In particular, my own research questions were, can a program manipulate language like a poet? Can a program assist human creativity? Can a program think like a poet? Can almost all of the reasoning be performed using only words and the WordNet dictionary and stuff like that, and not some RDF ontology thing from Wikipedia or from the site guide, Leonard in Texas. See how far I can get with that. And I'm interested in writerly thinking. So literary writers think about words, how they work, how they sound, and how they interact. So I came up with an idea I call a halo. No, I have no idea why I call it halo. It's a way of doing subtext or mood. I think a gentleman in the front row was, or was a different gentleman who's not here, was talking about mood types. So what is a halo? A halo is sort of like that search thing that I showed you before. So it's a bunch of words. So here's a happiness halo. It's words that sort of refer to happiness. You start with them and you fan out, and you end up with a kind of a structure like this. And so then when Inkwell is doing word choices, and they say, I want to use the happiness halo, then it will sort of, if it gets close to these words, it favors them more so than the other words. So for example, if I take the first line of the last stanza of that poem, the woods are lovely, dark, and deep, and I say, use the happiness halo, it says the woods are fine looking, not too light, and heavy. Okay? So light comes from buoyant, which is in the happiness halo, heavy comes from ecstatic, and fine looking comes from pleasant, because here is the combination of the search space of synonyms with the halo influence built in. And so in particular, lovely, the halo word that's closest is pleasant, and that comes up with fine looking. The word is dark, the halo word is buoyant, that comes up with light. This is showing the interaction, and then there's deep, the halo word is ecstatic, and it comes up with heavy, which is not that far away. That's kind of interesting. When I put in the anger halo, so now we're starting to understand what I mean by an angry type theorist. The woods are lovely, dark, and deep, it produces. The words aren't very ugly, not too light, and not too shallow. So the halos can attract or repel. So if you put in positive words, that's you say, here's a word and I mean this, then that will boost the evaluations that Inkwell does. If you put in negative words saying, don't use this word is the opposite of what the halo is, then that repels, pushes away words. Okay? This is one of those fixer-uppers, Jenny. So, what do you get when you obey Engrams? What do you get when you read in a whole bunch of text, machine learn stuff, and Markov roll out them into text in the machine learning style of things? Nothing new happens. You basically do what's been learned already. If you use the Engrams, then you're just going to be repeating stuff. Nothing new is written. So, thinking like a writer. So I need to reason about the sounds of words. Fortunately, Carnegie Mellon has a pronouncing dictionary. It has the sounds and the rhythms of words. It's designed for speech technology, so taking text and pronouncing it. And I also found the Merriam-Webster rhyming dictionary. Processing it is like the Google Engrams. Problem number 5. There's only 125,000 words that come from that. Inkwell has to be able to pronounce anything, any string of characters whatsoever. So I machine learned pronunciation tactics using the CMU dictionary, and then I use an algorithmic fallback. If it's not in the dictionary to begin with, then an algorithm based on the machine learned thing comes up with it. This is some words from the dictionary, so here's fictionalized. So the format of the pronunciation is there's the sound and then the stress level 0, 1, 2. Fictionalized. Okay. And then here's some machine learned ones. Dysphoria, dysphoria. So that's artificially produced. Actually is pretty good at doing this. It's good at figuring out acronyms. So if you type in the string IBM, it pronounces it IBM, rhymes with, IBM and M. And so algorithmic rhyming is computing for words and phrases starting at the ends of the phrases or words, how much the things rhyme, and then sort of decaying that as you move forward. So fictional and critical rhyme by about 50% using the rhyming algorithm. It's a related concept that poets use called echoes. So it's basically a rhyme, but the order doesn't matter, just the same sounds. And it's biased a little bit if it's more like a rhyme. So if it's in the same order, then that gets counted as more. So fictional and critical echo by 70%. So it's just the same, similar sounds. So what does that mean? So notable echoes of the phrase computer programmer from the King James Bible provoked me to anger. So that's the phrase in the King James Bible that sounds the most like computer programmer. Come on, that's funny. I have a book of essays, the one at the bottom, and it has the dull, most sound-alike thing, program a computer. Okay. This is a peat fire. Problem number 6, the woods problem. Whose woods these are, I think I know. So this poem was one I worked on a lot as an example. And woods is a hard word to deal with because if you just start with woods and fan out, there are only 14 synonyms and it just ends. It wants to use words like wood instead of woods, so the material rather than the forest. There are people's names like James Wood, so Inkwell gets horribly confused by the woods problem. And it's the very first word that it chooses in the poem, stopping by. So the halos seem kind of interesting. They seem to be a way of characterizing a word's meaning. So we came up with this idea of a sense, and a sense is a data structure consisting of words and relevances. It's based on the decaying synonym network spreading idea, more or less. And it can be used to compute semantic similarity by basically considering these words and relevances as vectors and doing cosine similarity, cosine distance. So then what you can do is define a sense, which is a set of words, and then scan it over all of the words in WordNet, use the WordNet entries to construct what that word sort of means, and then find words that mean roughly the same thing. Okay? Turns out that even though I didn't use a vector, this is isomorphic to the word-to-vec embedding that everyone in natural language processing and machine learning uses these days. So, if I have the noun animal and the sense, it's like a dog, it's like a wolf, then the sense looks like this. Here's the dog part, here's the wolf part. If I have the woods problem, then it has the words, the positive words, forest, tree, and woods, but it says, but not like wood, not like the material. And so if you look at that, the ones that are black are the positive senses, the ones that are orange are the negative senses. So it's sort of saying, here's this sort of landscape, this terrain that maps out the meaning, which corresponds to woods. So instead of stating a word to find synonyms of, you can say, choose a word that means the following thing, okay? So I can say, pick a word that means an animal, and it's the sense dog or wolf, and it comes up with these, which are kind of sensible. So it searches every word in WordNet and finds these. So that turned out to work pretty well. The overall structure of the program is like this. It takes the template and a bunch of constraints. It compiles that into an optimization problem. I put that into a parallel simulated annealing engine. It produces an English text. This is where all that adjust word and stuff is. This is the knowledge of English is just right here, and it produces the final text. So here is the full template for that Robert Frost poem. Up at the top are a whole bunch of global constraints. So this refers to the writer that you've selected. So it says, use their personality. Make all the words echo as best you can. Make sure they're all different. Use short words. Typeset it like a poem. And then you can see all the chooses: verb, cognition, no, and certain, queer, odd, unusual, weird, demented, stupid, silly. Here it says, whatever you pick for word 2, W2, make sure it's different from W1, but they have to rhyme. So you can see this is setting up a whole bunch of constraints that the optimization has to obey. So the second half of the poem looks like this. So here it's saying the word W3 should echo with that one. There's probably nothing else that interesting in here. So now the center point of the talk. The poem Stopping by Sums on a Snowy Mean Solar Day by the Roberts, Frost, and Harper. Harper is the type theorist, and I used the anger halo, and I used the previous template, and this is what it wrote. Whose sums these are I express I know, his unit is in the body though. You will not see me entering existing, consider his sums operate up with snow. My smaller horse must evaluate it interesting, to keep in without a family discriminating between the sums and polar form, the darkest mean solar day of the fundamental quantity. He gives his influence devices an exit to pass along if there is some statement. The only other element is the use of benign context and yielding element. The sums are logical, insensitive, and severe, but I have expressions to position and large indefinite amounts to go before I sleep in, and large indefinite amounts before I position. So let's look at some other things. What is this going to say? I pick a word that means like, favor, or love, then either something like happy, sad, or angry, and then an animal. No personality target. This is looking at the personality thing. I love happy dogs. If I say be extroverted, it says I love passionate bird dogs. If I say be neurotic, it says I yearn for humiliated attack dogs. If I say don't be open, it says I relish unclean house dogs. So the Engrams, again. So you can put it in a thing that says, pick an animal. I'm too lazy to figure out if it should be a singular or plural verb. So use the Engrams to select the right one. And it says, dogs are animals, toys are animals, huskies are animals, because there is no dogs are animals in the 3 grams, but in the 2 grams there's dogs are and are animals. Okay? And there also, these bad ones exist, but they are lower frequency. Then Wheeler said, every problem can be solved with indirection. There's Gabriel's follow-on to that. So every other problem can be solved with the null thing. So there's this concept of the null word, and it's used to eliminate stupid words. So here it is. Animal, it's dogs, it's is or are, and then it's an or nothing, animals. And it comes up with pups are animals, dogs are animals. So it eliminates a or an, because the Engrams say those don't make any sense. So the other thing is, all of these constraints can be positive or negative. If I say, well, use uncommon words, don't use any 2 grams that exist, don't use any 3 grams, don't use any 4 grams, come up with something new, have a lot of music and echoes, and it comes up with I hero worship easygoing working dogs. Probably a sentence you wouldn't have thought of saying. So in December of 2014, when I saw all this stuff, I said, I wonder if this thing can write poetry. So I hacked up something in an hour or so. I ran it overnight, produced 1,000 haiku, and it actually worked better than I thought. So there's sort of a haiku language, template language, that makes the templates easier to write, does all senses and not direct lookup, and has constraints for saying that certain words should be related or unrelated. So that one turns into oak trees and the moon, light and mute constellations, the bone-chilling sea. Again, you can sound like someone or sound unlike someone. That previous dog one, King James Bible, I love holy dogs. Anything but the King James Bible, I favor Madden curs. Okay. Novelty seeking. So if you can choose to not sound like something, then Inkwell can choose to not sound like itself. So you can put it in a mode where it generates haiku or generates poems. It remembers but kind of forgets after a while what it wrote. You have it write for a long time. It's really struggling to find new things to say. So here's another one. Avant-garde Cooper Union for the advancement of science and art, setting on fire the half-deep, fat-fried, ship-towed, long-range acoustic detection system. Probably not a poem that any one of you except for Quarks would ever come up with. So, it's not a software engineering project, it was just me. It's not designed in any standard sense because I didn't really know what any of it would be like. I consider it a research colleague, and so I write a poem a day as my part of my poet habit, and sometimes it helps me write the poems. The problem space is a mystery to be explored, not a problem to be solved. And the slowly dawning insights like the one you've seen sort of guided the whole thing. It's a platform, so I've only talked about the stuff in orange, but it's got all kinds of machine learning stuff in there. It's got a bunch of symbolic AI stuff in there. And I think it can do stuff that purely machine learned stuff, as done today, can't do because of the symbolic AI stuff. There's a debate we can have about what that can mean in the future. So how big is the thing? There are 50 million Engrams from Google. I have 160 writers it knows about with 100 to 1 million Engrams per writer. It has 500,000 pronunciations it's come up with. It has 800,000 adjust words. It has 165 inverse of adjust words. It's only 63,000 lines of code, so it's quite small. When I load all this in, it's running, it's 15 gigabytes. This is what it looks like. So it's hard to see, but there is some modularity in here. This does not include the web server code. It doesn't include the template compiler. So the Misfit function, we saw that nice small one at the very beginning. This is the Misfit function for the Bob Harper poem. So you don't have to understand the code, just notice how big it is. So this Misfit function is calculated during the compilation process. Then it gets compiled by the common list compiler, and then it is invoked in the inner loop of simulated annealing. So if I ask Inkwell to spend about 2 minutes rewriting the Frost poem, then that function's invoked 200,000 times, algorithmic rhymes invoked 3 million times, algorithmic echo is invoked 181 million times, Engram computation 400,000 times, personality computation 1 million times, and all different, making sure that every word is different 200,000 times. So if I didn't go crazy to try to make it run fast, it would take forever. So everything that can be done in parallel is, lots of stuff is pre-computed. I use parallel simulated annealing. I don't know if it really works well or not, but it seems to. I have clever representations. I have big caches and lots of them. And I basically ignore synchronization. So I have data structures and everyone's bashing on them at the same time, but I don't really care, so I'm a Reinhardian guy. And so what does correctness mean for Inkwell? It doesn't crash. So it just never crashes. When something goes wrong, there's only interesting wording as the symptom. When errors are caught, heuristic alternatives are used, so errors do happen, but it says, oh, you didn't do that, let me try some machine learned or some heuristic thing. The large data structures are periodically verified and repaired if they sort of get out of whack from synchronization. And when the very few engineered algorithms don't work, there are machine learned alternatives, and usually they're in competition with each other. So the last part is, Inkwell works when it knows what it is you're trying to say, even though craziness is good for creative writing. So one of the more recent things I worked on was trying to figure out what sentences mean. So not like, well, for example, if I tell it, what does this mean? I like dogs that bark and growl. So it produces a parse and it says, by dog, you mean a domestic dog, because bark and growl tells me so. If I say, I like dogs with bread and ketchup, it says, oh, by dog you mean wiener, because bread and ketchup tell me so. So this is using the cosine similarity. It uses the parser to figure out what parts need to make the sentence the most together. And this next example, I did not write myself. That woman is a dog. And here it says an adult female person as opposed to a man, dog, adult, unattractive, unpleasant girl or woman. So it figures those things out. So I did an experiment where I took 18 of these haiku to a writer's conference. I passed them off as short poems I've been working on. And as this runs out, you can see the comments that were made and the poems are produced, and otherwise the talk is over. Questions?
Yeah, so you're a trained writer.
Yep.
What did this teach you about language during this exercise?
That it taught me something that I was told earlier in being trained as a writer, which is if you've got a choice between A and B, then you're probably going to come up with more opportunities to say something profound if you pick the stranger of the alternatives. So basically, it taught me ways of being able to let go of rationality, which is one of the hardest things to do for someone like me in Quarks. So that was the main thing. Formalizing what was meant by reasoning about the sounds of words, the rhythms of words, reasoning about the meanings. That sort of clarified a lot of issues for me.
You said that you have one routine that handles the English grammar-ness,
Yeah.
but then you showed an example where it said the wood isn't not too ugly.
The Engrams decided that.
Okay.
So it's not built in. I downloaded the Google Engrams, and every English writer from 1910 to 2010 told it that. So the program didn't know.
That's interesting.
It's just the data said, these are not common, these are common.
Because I noticed in another example, or maybe it was the same example, when it negated the verb, it negated all of the objects.
Yeah,
Not just one of them.
so that's part of the adjust word.
Okay.
So adjust word takes any word or phrase and you say, I want the plural of this, or the past perfect, or the negation of it, or put it at the beginning, or in some cases, what articles go. That's all part of the adjust word thing. So that's all isolated in this.
That didn't happen for free with Engram.
No, it didn't happen with Engrams. So there was a hand up in the back. You.
Yeah. In good poems that are generated by human writers, you often have deliberately ambiguous words, and
Yeah.
almost always deliberately ambiguous sentences and statements. Right? You are talking about taking a walk, but you're actually also talking about the loneliness of life. So, have you tried exploring that, or are you?
Yeah, so I didn't talk about that too much. This haiku DSL, language for producing haiku tries to do that by exploring a theory of metaphor. That basically the templates say there's two sources of information for the templates. One is what the template says, and the other is it either takes what a person says, write about this, like the loud blues guitar music. If you don't specify that, then it goes through, it picks a writer randomly, it looks through all of that person's text. It finds an interesting paragraph that's talking about a coherent thing and uses that, and it uses the information in the template as a kind of a metaphorical mapping, and tries to adjust the word meanings so that it tries to do that. So it's just part of the research on how to do what you said. But the haiku, the poem writing thing, tries to do that in a so-so way.
I'm wondering how much of this you think translates to other styles of writing. In particular, something that might be of interest to this crowd is technical or scientific writing. Like, could you give it a not very well written paragraph of technical writing and have it give you something that's actually interesting to read?
Yeah, so the more like information transfer you want to use this program for, the less good it is. And that's because it has a very limited repertoire of ways of transforming sentences into other forms. The only direction of inquiry that I looked into that's related to what you said was there was a request from the DARPA people to take paragraphs written by medical folks about bullying and sexual deviance type stuff, and then write that so that a fourth grader could read it and understand it. And so we looked at that quite a bit. So finding the vocabulary they would use, and that worked sort of okay. But the being able to say the same thing in a more interesting way and also precisely requires something like the very last thing I showed of making sense. Really has to reason more deeply about what it is you were trying to say, making sure you're preserving that meaning. And I'm still working on that. So it's harder, so the poetry is more fun anyhow. Yep.
What Lisp implementation are you using these days?
Lisp works. So the reason I use Lisp works is it's good at grabbing as much RAM as I've got. So when it's working, the basic size is 15 gigabytes. I have 3 sizes of Engrams I use, and 15 gigabytes is for the very smallest one. When I put in the biggest one, then it's like 40 gigabytes of data. So I need to have that in RAM for it to perform at all. So when I started all this, I considered it a big data thing, not a machine learned thing. There's about a dozen machine learned parts to it, and there's probably about 6 or 7 places that are sort of more like symbolic AI. Jenny?
But it does help you write better poems yourself.
It does because it's relentless. And so if I want to, so I use it as a writing companion. And what I will do in that case, I'll say, here's something I want to write about. I will then set it up to run, usually overnight. I have it write about 5,000 poems. It's relentless. It doesn't get tired much. It really doesn't care about making sense if I don't want it to. And then I will cull through them, find the interesting bits and pieces, and I will put them together myself. I have published poetry jointly written with Inkwell. On Facebook, I routinely publish poems by Inkwell. When I took those poems to the writers' conference, even though the day after the writers' workshop, I had a class whose title was, "Is my program a better poet than you are?" They were shocked that the program wrote the poems that they had criticized the day before. They were angry. They were very angry. So it's very good at exploring part of the space that is hard for people to do because they're kind of focused in on something that they can't break loose.
Be used to explore meaning, so to connect different bodies of works and see how different types of authors talk about similar or dissimilar things.
Yes, and in fact, there's a whole bunch of analysis stuff that I didn't talk about, and I'm not going to find it quickly, but for example,
Because there are lots of discussions about different streams or schools of thoughts in a certain discipline that have different ontologies and different vocabularies, but sometimes the differences are not that great, that big, and if there were some ways of checking the meaning, well, people would realize that within a cloud of, that things could be mapped more easily than we can think.
yeah, so there's a whole bunch of analyses that Inkwell can do. That one is to consider all of the work, all of a text, big text, as one of these word-to-vec things, and then use cosine similarity to see whether how much two texts talk about the same things in the same sorts of ways. That's an Engram cosine similarity. You can do that with the personality, which pieces of text are the same, closer in personality. There's the overall musical, how similarly they use the sounds. There's a second way of doing that. So this is an analysis of a bunch of texts by Engram similarity. And so so here in this cluster, it's hard to see, but it's clustered together as talking about the same thing in the same sort of way: the King James Bible, the New International Version, the Jefferson Bible, and the Quran. So Inkwell is able to figure out that those things are basically very similar texts. When you look at the musical thing, they're not as similar as you would think. It puts Bob Harper right next to categories for the working mathematician, so you shouldn't feel bad about that. So yes, I think you can do that. Another thing that I've used it for is taking a single text, which I suspect is written by multiple authors, and finding the paragraphs that are written by the individuals.
Have you gotten anyone else to try using Inkwell as a writing companion?
Not alone. I have sat with other writers, and we have done that together.
And what happened?
They were surprised at the different connotations and meanings of what they originally wrote that Inkwell discovered that they weren't aware of. They said, "Oh, I had no idea that this could be taken by someone to mean this other thing." and that was interesting. So it was basically enabling them to explore around the space they thought they were writing in, and they had ignored. They couldn't see it because it was on the other side of a barrier. So they thought it was a good analysis tool to help them understand their own thing better, and thereby revise it better.
Unrelated question. You mentioned that most of Inkwell doesn't depend specifically on English. How much experimentation have you done with non-English languages?
0. Anything else? All right, go and eat. Oh, you want to ask? Sure.
How can we validate, assess the quality, the emotion that can be like emerged from reading a poem that was computational? I don't know, maybe this is called computational poetry. But how can we assess the quality? I don't know how to do.
Well, I don't either.
Is there a type system for beauty? I don't know.
Yeah, so there's a type system for beauty. There is the usual Turing-like way, basically hand them to other writers or people and see how they react. It does the stupid thing of computing the personality of what's produced. And I say personality, so there's the big 5, but there's about 15 or 20 other things that are emotional content, attitude, mood, that are also been machine learned by some other groups to sort of look at that. So you can do all of that, but I don't know. I really don't know. I would like for it to be able to reason consciously about what it's doing. It's doing it sort of semi-consciously now. So I don't think it's as aware of what it's doing as I would like it to be. So I would like it to, as Jefferson said, actually have written something based on emotions felt. And I don't think that Inkwell has any emotions that it's feeling, except for tired because all the garbage collections. Anything else?
Have you put this graph and related results anywhere that they're publicly visible?
This stuff here? No, but I plan to. So for a while, as I hinted, there's a web server for Inkwell, and it was online for a couple of years. If you had stumbled across it, you could have used the thing. But I took it down because it's also my mail server. Slow machine. Yeah, I'm going to put this up somewhere. And eventually, the Inkwell source code belongs to the people of the United States of America because it's developed for a DARPA project. So it's not owned by anybody. Bye-bye.